meeting is being fixed. Okay. All right. Okay, so hello everyone. I'll just check again the list of names. I would expect more to come, but we can say that as per the attendees now, we have two new attendees, Muhammad Abdurrahman and Abdul Latif. Both are from one of our partners in Qatar. It's called the QDS. Okay. QDS. What is Q for? Abdul Latif, sorry. Abdul Latif. What's the QDS mean?
It's Qatar Data Mission System.
Okay. Okay. So it's Qatar Data Mission System. All right. So both guys are good at the operations side of item suite and also the service management, as far as I know. And recently they are exposed also to be certified in Kubernetes, in, let's say, OpenShift and Red Hat. So I wish them all luck. This session actually, because you are just joined, this session is actually session number 4. All the previous sessions were called Docker, Kubernetes, and CDF, because the main objective of all these sessions is to make you ready for Container Deployment Foundation created by Micro Focus, which is based on Kubernetes and Docker. So this session should be directly going to Kubernetes, but if you allow me to just review few slides. Okay, so this is one of the slides, which is actually creating Docker image. Okay, I expect that someone, maybe all of you have some knowledge about Docker and the images. In as easy as this is the architecture, there is a global registry. There is a global place where Docker, you can upload your images there. Okay, so you can, by one command, by these commands, you can get one of these images for one of these applications, and you can run it locally in your servers. And every image you get from the registry, it will be executed as a container, and that container is isolated in memory and everything. You can expose some configuration from, or some, whatever you want from this container to other containers, or to the public, or to other devices, other users, whatever you want. So the beauty of the images is actually because it's structured, so you can get like a base image, like basic operating system, and then you can add whatever you want on top of this image, and then you can build an application on top of that. So as a sample, there is a sample available online where in the Docker online help. So you can do this exercise, which is building an image from Python, and then make a working directory /app, which is not a big deal. Then add whatever files you have in the current location into this folder, and then run few commands to get the libraries needed for the Python web application, and then expose port 80 from the container. Okay, and here define some environment variables, like environment variable called name and value is world, and execute a command called Python and the application app.py. Okay, so it uses these commands. These are sample of the files. This is application based on Python, which contains these lines. Okay, this is quite wrong. Okay, so this is not correct. I think it was Flask and something else. But anyway, one is empty like this, and one is with full data. So here we have like it creates a connection to a Redis server, which is like a small database, and then it display website, let's say HTML, say hello and name and the variable name, and then host name, it gets the variable host name, and then here it gets a calculator of number of visits, stuff like that. So on the next, these are the steps. So you have a file called Docker file and apt.y and requirements, and then you can type Docker build, and then you give it a name. Then you check Docker repository, local repository, you'll find there is image created. Then you can write a command like this to run the Docker image. So a new container will be created, but here we are exposing port 80 in the host as port 4000. And here you curl or command URL this host port 4000, and it will give you this page. So you have like a container up and running. Okay, so here, after you do that, you might want to upload it to the Docker Hub. So you might use command like docker push, and then type your username here, and then the image name, and maybe you add versions if you want. So, but before this step is actually renaming the friendly hello to be your name / friendly hello. So you will see that the tag is updated here. Then when you push it, when you push the image with that name, which is your ID and Docker Hub / the image name, it will be pushed to Docker Hub. So last time when we started Kubernetes, we have gone through some of these slides. I will start from this point going forward. Okay, so is it okay? Just this is small review, then we can go forward.
Yes, sure.
Yes.
Okay. So as per the last presentation, I had the same logo added, and this cloud that it's like teasing everyone. Okay, I'm translating last session the Arabic words that I have used. Okay, so where is the problem we have with Docker? First, if we have Docker host, one host, and then we create containers. But if we look to any application, the application might contain like, let's say 3, 4, 5, 10, whatever number of containers. So if you want to manage these containers and you want to distribute it and you want to put it in some of your hosts, if you have like 4 or 5 Docker hosts and you want to deploy some on the first host and some container on other hosts, managing this will be hectic. Yeah. Okay. So this where we need more tools, we need more automation, more things to automate these tasks. Actually, it's not hectic. You can make a command on node 1 and then make another command on node 2 and make another command on node 3. But what we are looking for, we look to maintain this in an easy way with like one single command. All these commands should be executed. I gave example last time about this Docker file and the image. Okay, this Docker file for us is actually executing 5 commands. This is the first command, let's say. This is the second command. This is the third command, let's say. And this is the first command. Example, just number of commands. When you make Docker image, what happens? You save all these commands into one specific image. So all you have to do is you say Docker run this image, and that's it. You don't need to execute these commands again. So Docker actually is automating these 5 commands or these 10 commands or these number of commands into one command, which will be a container. So Docker is very good in automating such activities, but we need to automate the creation of containers, the exposing of containers. So we want to execute this command 1,000 times, 100 times. Okay, so this is where we need more features than just Docker commands. So this is one, which is executing multiple or Docker command or Docker run many times, as many as possible. And we want each time to be with specific, let's say, image, with a specific environment variables, with a specific whatever. Then I want one command to execute when I execute it to deploy front-end containers, and another command to deploy back-end, another command to deploy a cluster services, or let's say a load balancer IP address, which loaded the traffic to the front end. So I want many commands, and I want something to easily do this for me. Also, if an image goes down, or let's say, sorry, if a container goes down, I want something to maintain the high availability of the containers, and to make auto healing. If a certain, let's say, host goes down, this host is hosting like 10, 20 containers. I want to be able, or I want somebody to be able to watch this, and if something like that happens, it will push these containers into another machine, or try to restore them on the failed machine, anything like that. Also, I want somebody to monitor the traffic to these containers, and if there is any like requirements of scaling up, okay, it would go for a scaling. If it goes scaling down or scale across systems, okay, scale out. So I want more than just Docker run command. So this where the need of clustering the solutions on top of, or clustering automation on top of Docker. So these are the features that everybody might look for to have a schedule capability. Like, I want this container to be deployed only on hosts that has enough CPU power or enough memory, or enough remaining CPU power, or enough remaining memory. Okay, so I am sure that this container, when I push it to that machine, it will start successfully. Okay, I want also, sometimes we have, let's say, if you access Google search, okay, you will see like image, which is a welcome image of Google, which is sometimes it's changing every day, or from country to country. This image changes based on the season. Like yesterday was like the Workers' Day, okay, or Labor Day, whatever they call it. Okay, so it should be changing to something related to the labor. So I want this container to be able to generate the image for me, and there is container that is a search container itself. So I want them to be set to next to each other, because there will be always, when user access the website, they will be always loading for that image, or loading the image that was processed on that container. So I want to put X near Y, which we call it affinity, okay, stickiness, stuff like that. Yeah. Okay, I want also not to deploy one single application. It means few containers, okay, front end, back end, and databases, and many stuff like that. So I want to be able to deploy the application multiple times, one for production, one for testing, one for version 1, one for version 2 and 3, and whatever. So I want to be able to label the containers by application version, by labels like these are front end, these are back end, stuff like that. Okay, so these are the features I'm looking for in the scheduling. In the replication, so I want this specific image, which is a container image, to be 5 containers, to be 3 containers, to be 10 containers, because I want to distribute the load on many instances of that specific image. So if I have a website front end, I want this website to be 10 copies of that website. Okay, so this is an application. we had already spoken about the handling machine failures. Okay, there is also a feature that you may be, or it may be needed for application. Like if I deploy 10 copies of the front end, okay, so how the other machines, or let's say end users, will access these copies, they should access from a load balancer, one IP address. But this load balancer is actually redirecting traffic to one of these copies. Okay, so if I have 2 copies now of a certain image, okay, and tomorrow I have traffic, or I have more traffic, then I created like 5 more, so I have 7 instances. So I want something within the tool to be able to discover where is my front end, how many of them are now available, and then redirect the traffic based on this number of containers. And whenever the traffic goes back to normal and then scaling down happening, so I want this feature to discover that the application has been scaled down and everything would be okay. And also we need a tool that help me to inspect what's actually happening. Some other features I will keep it for you, because it will be like repetition to what we have discussed. So many companies developed such capability. So I think Apache created Mesos, okay, Mesosphere, which is having the containers capabilities, scaling up, scaling down. It's a very, very, very famous and rich. Okay, and Docker, the one who make a best containers today, they also make a container orchestration tool. Okay, they call it Docker Swarm. Nomad, it's a very another orchestration made by a company called the HashiCorp. Sorry, it's very famous by another tool. It's called etcd, but anyway, it's another orchestrator. And Google, in their own labs or in their own production systems, they said for 16 years they are using containers, okay, and they are using something called the Borg and Omega, okay, and they are using the scaling up, scaling down capabilities. So what happened? They created a project, an open source project called Kubernetes, okay, based on their 16 years of expertise. Okay, so they make this Kubernetes out of this Borg and Omega, and all these orchestrators are available on the market, and all of them are used. But today, Kubernetes becomes more famous, okay, since they are Google, what we can say. For the container deployment foundation, Micro Focus chooses Kubernetes because it's highly adopted, and these are the reasons. Okay, so if we dig deep, okay, so Kubernetes is like governor, the word coming from governor, the one who's driving the ship, maybe. Okay, so the main feature is to be able to manage container clusters. The word clusters here means the nodes that are hosting Docker images and Docker containers. Okay, or let's say that the nodes that are hosting containers without the word Docker. Okay, this Kubernetes, which we have today, you can install it in your machine. You can install it on a server, VM, or physical machine, whatever. And if you have already cloud accounts on many cloud providers, let's give examples of AWS, Azure, Google for sure. They have an instance running there based on Kubernetes where you can deploy your applications directly. This Kubernetes is 100% open source. So if you found any feature that you didn't like and you want to add and you want to to make it available for the community, you can do it. It's written in a language called Go, which is also developed by Google. Okay, so if you want to enhance it, you can enhance it. Many people are enhancing Kubernetes, and make it available for the community, and many other people enhance it and make it for their own. Let's say like Red Hat, for example, in OpenShift. So they make lots of enhancements to Kubernetes, and they repackage it again as their own solution, which is good. I mean, nothing bad. We may say that Micro Focus also enhances some of the features of Kubernetes and make it for their own, which they call it CDF, Container Deployment Foundation. I can easily say that some of the features released in latest Kubernetes, for example, when they write it there, I was like, oh, okay, this is not new because we have it in CDF. In fact, we have it based on our own development or enhancements we made on Kubernetes, but in latest releases, they make it available for everyone as Kubernetes themselves. Okay, themselves, yeah. If we take Kubernetes as a situation, as how everybody sees Kubernetes, we can say that for users like admin, or let's say operator, developer maybe, all they have to deal with is either command lines or APIs or through the user interfaces that is available with the Kubernetes. In reality, at the back, there is a server, at least one server hosting the master functionalities of the Kubernetes cluster, which is hosting stuff like this, whatever written here. And there is nodes that communicates with that master or with servers that are doing the master job. And they are taking instructions from the masters to be able to load specific images or application instances and so on. So this is like so far away or a general look for Kubernetes. Yeah. So you can say it's like this. Something, you execute command, it goes through APIs, which we don't care about them. We actually execute commands. And this APIs are actually sending data to the container cluster, which is Kubernetes, and do the job for us. Kubernetes, these are how Kubernetes are one of the leading in the community or in the orchestration software. This example of how it can be compared against others. And you can see here, it's one of the top 10 projects in GitHub. How many projects are based on it. Okay, there is meetings held worldwide for Kubernetes. Okay, where you can go and attend and you can get some new knowledge. One of them is like what we have today, but we are not announcing it as a meetup. Okay, many contributors. Okay, and there is adoption across different companies. Okay, like OpenShift, for example. All right. Okay, so it's this is just a summary of what's Kubernetes. It's an orchestration system for Docker containers. It provides a basic mechanism for deployment of containers, maintaining availability and the container settings, scaling them, auto restart, rescheduling, and replication. It's as easy as one node that is handling the main functions of the Kubernetes, which is called the master, and workers, which they sometimes had the name of minions. Okay, masters and workers are actually have Docker installed. Okay, the master has three main components. It can be more, but mainly three main components. One of them is the API server, where you will be able to send commands. So if you want to see what's happening there, if you want to instruct it to deploy new containers in one of the available nodes in the cluster, you communicate with the API server. It's REST-based API. Okay, there is also a controller, and there is a scheduler. There is many controllers actually. Okay, controller is like an automation system, which has the algorithm where it can say, okay, I want to schedule. I would say this container requires this much of memory, so I would say this should go to this machine. Okay, so the evaluation of the inputs and take decisions are actually the controllers, sending the job to the workers, which is actually the scheduler, and the workers, which is the minions. When they receive it through kubelets and then execute it locally. That's a very big, complicated stuff. What I can say, ignore about all this. I will repeat. Okay, so we have George as well. Okay, welcome, George. So,
hi, Mahmoud.
Hala. So, yesterday I had deployed a small article on how to get Kubernetes installed on your Windows 10. So in reality, there is a command called kubeadm. This is a command you would use to configure and to make a Kubernetes system, which will help you to install these functions like the API server, the controller, the scheduler, and in the previous screen, the distributed key value store, all this stuff. So, and because of this is an API server, so it's a web server. So because it's a web server, it's HTTPS. Because of HTTPS, it requires a certificate and very noisy stuff. So to make it easy for everyone, there is many ways to make it easy and to be able to deploy it anywhere. So in Windows, there is a tool called Chocolatey. Okay, this Chocolatey, yeah, they call it Chocolatey. Okay, so Chocolatey, it's a tool that is like a package manager. It has, let's say, let's take it from this. Okay, it's a package manager. If you go for packages, if you install this tool in your machine and you want to install Adobe Reader, you don't need to go to get Adobe Reader executable file and then double click install and select folder and next. You don't need to do any of these. All you have to do is type Choco, install, and Adobe Reader, and it will install it directly for you. You will find the icon available in your start menu. Same for Chrome, same for these tools. You can see many things. If you want, so from this day forward, if you have a new machine, all you have to do is to install Choco and then have like a script to execute all these commands. So you will get WinRAR, Media Player, GitHub, Readers, Booty, anything you might think of. Node, Notes++, everything. So adding to that, when you have a new machine, what you can do, you can type the same, Choco install Minikube. This actually creates a VM for you. Okay, it downloads the whole Kubernetes stuff, and it makes a mini VM for you called the Minikube, and it's configured to, I think, yeah, boot from CD-ROM. Yeah, and it has like ISO file, as easy as you can see here. It has ISO file where it loads everything from the ISO file. Okay, the changes are stored in this disk. So it's a very, very easy way to have Kubernetes into your machine. and it configures the Kubernetes command to launch and to access everything on this Minikube. That's a way. Another way, if you want to get the Kubernetes, you can have just this one, which is Docker for Windows. And in Docker for Windows, in the settings, there is a new selection here called the Kubernetes. And all you have to do is to just select this option, enable Kubernetes. So what happened? You will have Docker and Windows. At the same time, you will have this Docker enabled with Minikube built in. So either use Docker for Windows and just check this checkbox, or you can go for Minikube using Choco commands. It's up to you. Okay, and from here, from this place, which is Docker for Windows, if you have both of them, you will see that the Kubernetes option here recognized both configuration, Docker for desktop and the Minikube. And now if I execute kubectl command, which is a command for Kubernetes, it will go against this Minikube. If you want to be against that server, so all you have to do is to check this one. So it's like the client APIs will be redirected to the other VM. And for your info, this VM, which is a Moby Linux, is actually the one used by Docker for Windows. So the Docker for Windows is actually using this VM, which is Moby Linux VM. So that's part of the story. Okay, another place where you can get Kubernetes and to play with it interactively online, which is this one, where it's called labs.play with Kubernetes, K8S, it's abbreviation for Kubernetes. And here you just log in with your GitHub account or Docker account, and then click start. And it gives you 4 hours of session where you can create instances and play with Kubernetes. As you can see here, to initialize Kubernetes, all you have to do is to write this command. So now I'm initializing Kubernetes. Okay. So kubeadm is the command to install Kubernetes. And after this part finished, I would configure the Kubernetes cluster by the second command. And this command is actually for creating a load balancer on top of Kubernetes. Okay. These are the 3 commands. If you go through the items here, it will show you that we are creating the Kubernetes and all the prerequisites for Kubernetes. So, okay. I have already many environments that are available and loaded. Okay, one thing that I missed to tell you, if you are interested to have this playground installed in your machine to be able to add new instances and stuff like that, but you are not accessing something online, you access something in your lab, in your data center, and whatever, this also is a project available online. You can get it from the GitHub, and you can install it on any machine, and you can play with it on your own. Okay, so in GitHub there is Play with Kubernetes. There was a project called Play with Docker first, then they make out of it Play with Kubernetes. You get these files locally in your Linux machine, and then you can run Docker Compose up, and you will get it up and running. and you can play with it. Okay, and you access your machine on board 4000, and you can have environment that is running there. Okay, I did not yet complete it, but this is example of the result. Okay, it has a workshop where it has a lab like this. Here it should start your machine, and you could run all these commands. Actually, it's not started because I'm not following the instructions as easy as that. Yeah. Okay, so for example, I did not execute this command. I just played with the other one. Okay, so as easy as that. But there is a question. Okay. All right. So I muted Abdul Latif, but he can unmute anytime, I think.
Mahmoud,
Okay.
can I ask a question?
Go ahead.
So I assume that Kubernetes is needed only on kind of complicated environments, right? When you have multiple containers and multiple images,
Yes,
it's not needed.
Correct.
Okay. Just confirming.
Yeah, 100% correct. But if you look for any application, you will find that it's not advisable to make it as only one container. Okay. So you will have like a web server, and there is at least database where you store some data. There is functions that you might have on that web server. So by time, you will add more. If we take example of your applications that you created for the university, okay, so you deployed everything in one place. Okay, then what happened? Many users are connecting and using a specific function in that application that making the whole application overloaded and slow. Okay, so what you might do, you might ask the developer to split this part as a separate executable, as a separate application. So when users select the specific parts in the application, these interactions will be directed to another container or another machine, if we can say it that way. So from that, when you start realizing that there are certain areas that are taking much load than other areas and impacting the whole application, in that time you will start to split your application into components. And when you run these components, if you have one application, it will be easy to make it on all in Docker. But if you want to have like scaling up capabilities and stuff like that, that's where you go for orchestration tools like Kubernetes.
Okay, thank you.
Okay, most welcome. But let's say that, there is some people are against, let's say, Microsoft, and they don't want to use any tools coming from Microsoft. Maybe there is some other people are against Google, and they think that Google is selling their data everywhere. Example, yeah. Okay, so they might say, okay, we want the orchestration, but not from Google. So they might go for other technology. Stuff like that. It depends on the team that you are working with and what is the approach they want to take for automation. And as I said, Kubernetes and others are actually sending commands to Docker through APIs. Okay, so if you want to build your own orchestration from scratch, you can build it. It's not mandatory to follow a certain orchestration tool. You can automate these tasks yourself or automate the actions yourself. So the first thing that we need to explore with Kubernetes, I want to go into the next step. I will skip this one from the master and workers, and then I will move to the Kubernetes concept. So the first thing in the concept, the user.
Sorry for interrupting. I need us to share something also, which is very good. Maybe it will help the people who are there on the call. I have one website. I put it in the chat. It's also having an online training for Docker. So this website, maybe if you open Mahmoud, you will have a lab online, working always, and as well as with the steps on how to start in practicing Docker. So it's very good website. So maybe that it will be useful. Yes.
Right.
I believe this is the same one you opened, right?
Sorry?
I believe this is the same one you opened it.
Yeah, I open it now.
Yeah, but
okay.
open it is I believe hosted locally on your machine, right? You said that you have it locally, something like this. So that's why I thought it is.
Yes.
Or maybe I missed this.
Online. No. It's okay. Just because you may be new to this meeting. Actually, we like everybody to share ideas, and that's very good. If you found anything useful and you want to talk about that in the session, it's okay. It's not only me, and also George sometimes join us and discuss some topics. Anybody if you want to share anything, is much welcome. Any feedback, any doubts, whatever. If we couldn't find an answer, any of us, we have to investigate and we have to find a solution. And it's a good place where we can discuss things. So good. We have this training, .play with Docker. Yes, this is similar to the one I had here. This one is play with Kubernetes. And this one is,
how
you can say
similar? Sorry, Mahmoud. How you say similar?
Yeah.
Similar. Kubernetes will orchestrate Docker, no? It's the top
Yes.
level.
Uh-huh. So okay.
Or I don't understand correctly because the Docker.
No. You are right. Wait a second. Okay. Wait a second. No, I will tell you.
Thank you.
This website is called the Play with Docker. Okay. The whole exercise is here. Okay. When you click like on this stage 1, and it will wait some time to open. It will give you a training. It will give you a training session. Okay, let's go for this one. So it opens with this URL now, or this sub URL, and here it will load, let's say a server or anything. Let's see. Okay, so here you see, let's say a terminal. Okay, this lab is available online to play with Docker only. Okay, this exercises or anything here is play with Docker. Okay, there is another website similar to this one, but I don't have the link now. It's to play with Kubernetes. Same interface, same, let's say, most of the things, except the content, the article, the training, the descriptions, all that stuff is for Kubernetes. Okay, I think I have it. Let's play with Docker. Okay. All right. I don't have the link now. Okay. So this play with Docker is actually a web portal with a terminal to VMs, to other machines, where you can execute some commands. This project or this website, it's available here in Docker Hub. If you want to replicate it and to make it in your own lab for your own colleagues, you can go for this GitHub/play with Docker and deploy it in your VM, okay? And then you will get a copy of this lab into your machine, okay? So you don't need internet access, you don't need anything, you just use your machine to play with Docker, okay? So this play with Docker, they take it and they make another project, part of it, or subsidiary, or whatever they call it, clone, branch, whatever they call it, and they change the name to be Play with Kubernetes, based on the same concepts, same techniques, but for Kubernetes-related activities. Is that clear, Omar? Or I am missing something?
Yeah, Mahmoud, thank you. Yes.
Okay. So what I was trying to show you here that this is hosted locally in my machine. Full website, you imagine full website with whatever they develop underneath is actually available in my machine. And this is the beauty of containers. You develop it once and you put it into a container, and then you and then you make it available online or available in a certain registry, certain place where other, let's say, customers, users, contributors, whatever you call them, they can pull it again and launch it in their own local machine, okay, without having to reconfigure anything. So what I can show you here in this machine, I think this machine, let's say that machine, or let's say the Minikube machine. What I have done, I have just copied the files, the Docker, the GitHub files, these files from GitHub, and then in that directory, I made this command, docker run, and I specified that image. This is the user, and this is the image name and the version number, and that's it. So what happened? The whole project that gets downloaded into my machine, and then now I'm able to do everything locally. That's it. Okay. So I hope that's clarifying the situation. Same will be happening for this project. There is something called friendly hello, okay, available in my GitHub. So okay, if we go here, hub, the Docker. Okay, this is my account in Docker Hub, and here is a friendly hello. Okay, which is the example that is actually part of Docker training. Nothing special. And what happened? I deployed many times with many tags. Okay, and then I think I removed all other tags, maybe. So I made the image many times, many copies of the image, but I removed all of them except version 7. So here you can delete images that you upload. So anyone can go and get this image and use it in their machine.
Sorry, Mahmoud.
Okay.
This is a registry for Docker, no?
Yeah, it's a Docker registry. Yes, it's Docker registry.
Okay, good.
It's a public registry available for anyone. Okay, I think there is some sort of limitations. Okay, but it's a registry that you can upload images and you can download images from others. If I go for Explore, for example, here, Explore, I can see applications, as you can see here. If I want Ubuntu image, if I want Nginx Security Access Manager from IBM, Node, again, MySQL, anything. Many more. Okay, so some of these images are certified by the official images. These are all official images, and somebody can make his own images, okay, and may certify them if he wants. So that's the registry where you can get anything from that registry. If you want to know what's in the registry, all you need to do is, I think, Docker search open to Docker search. It searches the registry and tells you what are the images available in the registry with the name Ubuntu. Okay, so it shows, let's run, yeah, it shows Ubuntu. This one is official. Okay, it has stars, like many people like it, stuff like that, for downloading that. There is other Ubuntu images that many people downloaded. This one, Doro W. This one, 200. I think this one is like a trainer. So in the training, he tell them, go and download this image. That's why it's having that much rating. Okay, although it's not official. Okay, just I think. Ansible also has version. not official. Okay. Okay, it has automated. I don't know what is automated means, but anyway. So if you want to get image, like let's say Redis, this image, all you have to do is to type docker pull Redis. Okay. Sorry. Docker pull Redis. It will try to pull from the online store. Okay, so going back to Kubernetes. So what happened? Kubernetes tried to change some names in the game. So the smallest entity they have, or one of the smallest entities they have, is called the pods. So pods actually like a holder of a container, like in this case. So it's a container, as you can see, has one IP address, like you can see here. This IP address is the pod IP address, and at the same time, it's the container's IP address. In some situations, you might need the container to access external files. So you make like a shared volume, okay, or what they call it volumes, okay. You make volume, and you make this volume accessible outside of the container. So for sure, the container has many directories, many volumes, and whatever you write in these volumes are actually written within the container. If the container dies, all the data within the volume will die. But here, when you make this icon in this photo, it means that the pod is actually has a folder, or one of its folders are mapped to external folders in the host, or in a remote server, or in a remote service. Okay. So another capability they have added, that you can load multiple containers within the same pod. So in reality, it will be one IP address, but two containers. And here you can see 3 containers with 2, let's say, disks or volumes, whatever. Okay, so 3 containers, and it's called again pod, and it has only one single IP address. Can anybody explain this for me? How this is working? George, your feedback is necessary here if you are with us. Samah, he's trying to say anything.
Yeah,
okay.
no, you mean your question is how the pods are working? What's your question?
How two pods are sharing the same IP address? So here,
okay.
2 pods are sharing the same IP address.
Yeah, because they're on the same. It's not the same IP address. It's 3 and 4, right? I see different IP addresses.
Yeah, but here in this example, 3 IP address 3 has 2 containers.
Yeah.
How this is working? Okay. That's the question.
Yeah, but it's possible that because they're on the same host, right? Or that's the IP host?
It's in the same host, but no, this is a container IP address.
Okay, I see.
Okay.
It seems
like
the port is
it seems for high availability. Is that something like that, for high availability, to have multiple containers?
Good, but this is not what I'm looking for. But Muhammad Abdurrahman is trying to say something. Okay.
The ports, so they are mapped the services after.
No services. No services. It's a pod with one IP address, and inside that pod there is 2 or 3 or 4 containers with one IP address.
So they are connecting to different ports on the same IP address.
Different ports? No ports at all. Nothing. No ports are mapped. Nothing. It's just a pod that has one IP address. No, this is not what I want. Okay, this one maybe. Okay. Okay. Right. The secret is here. Okay. If you remember the old session or the other previous session, okay, this is a secret. Okay. I told you before there is a feature in the Linux. It's called kernel virtualization. Okay. They are using something called namespaces. Okay. If we access, let's say, this exit from this machine, ps-ef, okay, you will see something called C groups, right? You see it? Okay. Is it okay?
Again, Mahmoud, please.
You see something called the C group, C group, C group, C group.
We see it. Yeah.
Yes.
Okay. So this is the first part. In any container, when the container starts, it's added to something called the C group, control group, where you specify how much this container will be taking how much from the memory. It's actually not container, it's a process where you have a process and this process is loaded in memory and you say it's not loaded directly to the memory. I want to load it into something virtual group. It's called the control group, and you give it a specific maximum CPU to use, maximum memory to use, and maximum disk to use, and all that stuff. This is called C group. There is a technology within the kernel. It's called the namespaces. We discussed it in the last 2 sessions or 3 sessions. Okay, the namespaces are something to virtualize to the process itself. It is process number 0. So within a container, if you type ps-ef and you see the process loaded in memory, you will recognize that this process is process number 0, while it is actually process number whatever in your host machine. So what happened? We put that pod or that container into a namespace. Let's give it ABC name, okay? And when you work under ABC, the first process starts under ABC, it has process ID number 0, okay? So if you start another process in the same namespace, which is called ABC, so the process ID will be 1. Then another process ID will be, or another process will be 3, 4, 5, while all of them are actually loaded in the machine. So the same happen with, let's say, host name. So when you start first container in the namespace, let's say ABC, so they will have host name with that specific container name. Let's give an example here. kubectl get pod. Okay, what is this? Okay, sorry. kubectl get pod. Okay, you can see here this pod is 1 of 1. It has only 1 container. If I will tell kubectl exec, I think exec maybe. Yeah, exec, sorry. Exec this container, this pod name, bash maybe. Okay. Okay. So now if I type ps-ef, okay, there is no ps. Anyway, IP, ADD. There's no IP. All right. Okay, exit. Okay, so if I type host name, you can see the machine is called the friendly hello dash this, the whole name, this name. Okay, so the machine here, while I'm having only one machine called CentOS, whatever the name, but I have inside the machine another container that has host name. So what happened in reality, this container started with a namespace for that specific container, so it has a unique name. Okay, so inside the container, I'm using root, but this root is different than my other machine root. Like here, host name, it's a different host name. Okay, so the container, when it starts in an isolated namespace. Within that namespace, it has some parameters like what will be the process ID. Okay, so what will be the process ID? What will be the network configuration, IP addresses and all that stuff, and what will be the folder that it will access, what will be the host name, and what is the user accounts and all that stuff. So what happened with Kubernetes? Okay, let's make it again. kubectl get pod dash all name spaces. So you can see here there is this one CDF API. It has 2 out of 2. If we check this one, okay. Okay, if we check here, we'll see that has this specific IP address, 172.16.19.6, right? If we get what is inside this one, describe, okay. If we check here, under containers, there is container called CDF API, and there is another container called Kubernetes Vault Renew. 2 containers. Okay. So let me make it that way. Take this part here and go here. Okay. Containers 1, container 2, pod 1. Okay, let's name the pod ABC. So what happened? The namespace for network has 1 IP address. Okay, and there is namespace for containers 1, which has all this except network. So this is how it will be. There is a pod with the namespace network that has IP address, and the container 1 is participating in that namespace, so it has the same IP address. Container 2 has the same IP address because it participates for that namespace. So they have, but other namespaces for mounting, process ID, hosts are totally different. There is a namespace for container 1, and there is another namespace for container 2. So that's why when you look here, you can have 2 containers with the same IP address. When the first container starts, it declares a certain IP address with a certain namespace for that IP address. Container 2, when it starts, it's not creating another namespace for the network part. It uses the existing one. So the same when you create 4 containers within the same pod, it will be having the same machine. Any feedback? Positive, negative?
Always positive, Mahmoud.
No, anything. Okay.
Yeah,
Right.
it's clear, yes.
Clear. Okay. What is the pod? The pod is the controllable unit we have inside the Kubernetes. This controllable unit, when you send a request to Kubernetes, to the API, telling them, I have a pod, I want this pod to be deployed somewhere. Okay, so what happened?
Sorry, Mahmoud.
Okay.
One question, please, here quickly about these pods. It's because under Kubernetes there is master and other node. It's available for master and other node, or only for other node type?
Okay. I got the question.
Good.
Okay, so let's make it this way. Going back here into our play, this environment, we have only one node. Then we can initialize the network. The second step after we configure the
cluster,
the container, this one. Okay, so we configure the network. Then we will add more instances. Add more. Let's see if it's creating or not. Okay. Anyway, till it goes for creation. Okay, it's not adding for a reason. Okay. Okay, let's start another environment. Add node 1, add node 2, add node 3. Yeah. Okay. So here, this one is not adding anything. Okay. So I will work on the other environment just here. This is the first command, and that is the second command, and this is a third command. Okay. George, are you here?
I am with you guys.
Okay, we need some help, yeah, because
Tell me.
I made a complicated story about why there is 2 containers within the same pod.
Okay.
Can you give us an easy story? Why there is 2 containers within the same pod? What is pod? What's the definition of pod? Stuff like that.
So let's make it as simple as possible.
Okay.
A container is running an application. Now a service is a front-end service that is provided by, for example, it could be provided by a container. However, usually a service might be needing multiple application running in the backend, or multiple containers running in the backend. So, for example, what's the simplest example, Mahmoud,
Can I modify? I tell you something. Okay, I'm talking about pods only and containers within one single pod.
One container within one single pod. I'm talking about multiple containers within one single pod.
Okay, good, correct.
So,
yes.
so يعني why a pod is one level above of a container, or why one container might contain or need to contain more than one container? What's the use case? Why it's not just only containers? So the reason for that is simply that some service will require multiple containers to run, or one pod, or let's assume a pod is doing something, might require multiple containers to run in the back end, but those containers should be binded together. So an example here, I'm trying to figure out a simple example. For example, a container is doing function A. However, this function needs to be authorized. So there should be another container that is getting the authorization for this function. I tried to make it a simple example. It turned out
good.
It turned out so let's make it to the guys a little bit more simple. Assuming we have a pod, and this pod is doing a calculation. So we have this calculation. When we request for this calculation, we have a container in the back end doing this calculation. However, in order to do this calculation, we need to validate that the request, for example, is authorized. Just a simple example. So the container that does the calculation doesn't handle also for example, the going another function which is going requesting a token or authorization validation. So there will be another container that is doing this along with the first container that's doing the calculation. Another example could be that I'm doing a calculation at the same time. Once I do the calculation, I need to write it on a database. So there might be a container doing the calculation, another container that is writing on the database, and there should be binded together under one single pod. I'm not sure, Mahmoud, if I made it simple, or if you have other examples from your side.
Okay. How we get the Google search of US, for example? Do you know how? Google, like a Google, but in US. Like now, this Google in
you need
UAE.
a VPN, I think.
Okay. Google.com. Okay. But how we get the doodles of Google? Google doodles, like this. Doodles. This. Yeah. Doodles. Yeah. This doodles. Okay. All right. Okay. So, you see this image celebrating a new era? This one? Okay. This one. All right. Okay. When you open Google, you will get this, for example, on one of the days, like 1st of May, you will get this background. Okay. So I want to create an application to get GIF. This actually is GIF file, I think, if I'm not mistaken. This is GIF file. Okay, it's called Celebrating the New Era. In fact, this GIF, I want to have a GIF generator application that generates GIF from a certain folder, and then stores the data in that folder. So I have multiple files. Let's say, okay, I have new era -1.gbg, 2, 3, and so on. 2, 3. Okay, all of these files are in a certain place. this place. They are here, okay, in this place. Okay, so I want one container to process them. GIF generator. And I want another container to be my search engine. Okay, so the generator will create new era, okay, .gif. So every day when somebody log into my Google search, okay, I want the generator to look for the files with sequence and generate a file with that name. And then when you access the search engine, it should be able to reach that file. So what I will do, I will put all of them into one container, one pod, and I put container to make the GIF. And if that GIF generator has issue, my search engine should not fail. I need the search engine to be up and running as a container. No issue. It will not do much work, and the GIF generator will do the work. And if the GIF generator has issue while processing, if any failure happen, that container should fail without having my search engine failure. Okay. So what I will do, I will put all of them into one place. Okay. So I want these two jobs are actually working together in one place, or they are doing one single function, which is opening a website for you. There is image there, but that image does not require a separated pod. It may work within the same place. So I will have container one to make the GIF generation, and another one which will give me the website that loaded the GIF. This is where I have one application or one pod for both of them. So let me show you this in, not that specifically, but let me show you this job here. Okay, so I'll go for node 2 because the question initiated by about workers and so this is node 2 and this is node 3. We did this exercise before. It's nothing new here, but now if we type cube CTL get node, I would see there is node 1 which is working as master, and node 2 worker but not ready yet. Actually all of them are not ready yet. Anyway, maybe because we are missing the initialization of network, maybe. Okay, so I'm just executed this part. So get nodes should be ready after some time. Okay. Okay. Why is not really cool? Okay, now all of them are ready.
Okay, good.
Okay. Okay. So what I want to do, I want to deploy a pod like this one. So what I can do, as easy as this command, I can show you how easy it is to deploy a container into the universe. So we can get the containers, get cube, CTL, get pods to see if we have pods or not. We have only this 3 pods. So with one little command, okay, not this one.
Sorry, George, can you George, can you please mute your micro? Sorry.
Okay. Let's see who's muted. Okay, Omar.
Yeah, there is no.
Now I think it's okay, right?
It's okay. Yeah.
Okay. Okay, so now I executed one command called the kubectl run something called the friendly hello. Okay, from image mah Ibrahim / friendly hello version 7 and expose port 80. Now, if we get pods again, we can see there is a pod created called the friendly hello, and this pod is now ready. This one, if we type get pod / output white, we can see here that this pod is having one IP address, okay, and it's hosted in node 3. Okay, so what happened? If we want to know exactly what happened, we can type something called get events, I think. I don't know if it shows you anything useful. Okay, here we can see exactly what happened. That let's see from which, okay, from here, I think from this. Okay, 57 seconds ago, there is a bot created with that name, and that bot is scheduled. So there is a scheduler, which is a scheduler assigned that to node 3, and then there is something called the replica set created, and there is bot created. And what happened? They try to get the image, okay, and the image is successfully pulled from for sure registry, and the container was created, and that's it. If we want to get not all this data, we want to only get the data related to specific pod, we can do this. We can type kube describe pod, and we specify our pod, this, okay, or that pod, I think from here, the pod name. Okay, we can see many things, but the most important part, which is the events, the master, okay, the master server has a scheduling capability, and the scheduling said, okay, we want to schedule this pod to some place. So now they scheduled the pod to be deployed in node 3. And on node 3 itself, it tries to get the image of mah Ibrahim, whatever the image name, and then created the container, and then the container is started. That's as easy as that. If we look on the container details, we can see here, this is starting from the detail. The container has a name. It's deployed on something called namespace. Okay, and it started on this node, and this is the starting time. There is some labels, and what is the IP address of the pod, and then that container, that pod has containers within. It's just one container. Okay, and this is the container ID on Docker, and this is the image name, and there is exposed port 80, nothing in the host, so it's not reachable away from the host. Okay, and that's it. Okay, if we look on the conditions, it's initialized successfully, ready, container ready, and the pod is scheduled successfully. So it's true, so it means all these jobs are true. Okay, and some other details. If we want to see these details in YAML format, there is a command called kubectl edit, where we can see the data here in YAML format. You can see here friendly hello and the reference and some other details, and this is support number. So you can see lots of data has been actually written by just executing one single command. If you remember the command, which is called docker run, this command. Kubernetes run, and name and something. Okay. Okay, where is the difference? I didn't see any difference. Okay, so let's create again the same by using a YAML file just to finish the creation part. So vi file friendly. Okay, we'll say it Omar as an example, omar.yaml, and then we'll insert the content. So what we are writing here, we want to create a pod with the name of my web app. That's the name. Within that pod, there will be a container called friendly hello. I will, let's say, name it a friendly Omar. Okay, and that container will be based on image with that name, and here I specify some variables like host, Redis host. This is a variable and this is a value, and the port is port 80. Then I will write it out. So another command is called kubectl create. This if you want to create anything, and you create whatever you want to create. You put it in a file like Homer.yaml, this one, and then press enter. Based on the contents. Okay, sorry, I forgot that we need to have everything lowercase. So sorry for that. Okay, so I will do the command again. So what you can see now, pod has been created. The pod name is my web app. If I type kubectl get pod, PO or pod, you can see that the container now is being created. Get again is still in the created time. If I type describe pod and then specify that name, you can see here that ready is true, container ready is true, everything is true, and you can see the story that everything is created. If you type this command again, you can see it's running, and it has only one let's say one container. It's only one container. Okay, what if I want to have two containers?
Mahmoud, I'm sorry to interrupt. I just want to rush for one meeting, so I need just
okay. I will. Okay, you can go, and I will keep the recording.
Yes. Thank you so much.
Okay, most welcome.
Thank you so much, Mahmoud. Thank you, George. Thank you for
most welcome.
Thank you, Mahmoud.
Okay, most welcome. So now what I will do, I will edit the file again, and okay, here I will, let's say I will take this part again. No, it's not responding. Okay, something wrong happened. Okay. All right. I will try to make this my app too. I will kubectl create -f Homer Lucian. Okay. Okay, so the machine actually halting. Okay. Okay, I think now it's responding. All right. Okay. All right. So kubectl on this machine is not configured correctly. So what I will do, I will I will write the same file and then I will create the pod again. Happened. Okay. All right. So I will run the command again, and I'll get the pods, and I can see now. Okay. So now we can see that we have scheduling. Schedule give the job to node 3 and then start the containers image number 1, let's say, and then for some situation it tries to start the container and there is some issues happened. So we can see here friendly Omar is running, and the second one is not working. Okay, so we have the first one working, and then we have the second one is crashing. So what we have now, we can see that there is 2 containers within the same pod. This is a pod name. 2 containers. One of them is working. One of them is not working. Okay, so that's example of like having multiple containers within one pod, and you can see everyone has his own status here. Okay. Okay. So your question, Omar, was about scheduling. Okay. So what happened? We sent the command of creating that file or that example. We send that command to the master. Okay. With kubectl. kubectl actually communicates with the API. This API server. Okay. And when we send the data to the API, a controller takes the data, and based on the inputs, you have a pod file, you have a pod, you want to create pod. What are the specs? These are the specs. So this is the controller. Then he said, okay, we want to have this much memory, this much process. So they send it to schedulers to schedule it on a certain node. So the scheduler send it actually to node, let's say in this case, node 3. So the worker on node 3, which is kubelet on node 3, take the request and created a pod and added the container in the pod and do the whole work. Okay?
Good. Okay, Mahmoud.
All right. Do we have more minutes? Samah, are you available for a few more minutes or?
Yes.
For me,
okay.
Sorry, Mahmoud. For me, I must to leave now.
Okay.
Yes, please to share the recording link as
all
you.
Right. Okay.
As you know, to see to watch and to watch again the
videos. No problem.
Yes.
Yeah. No issues at all.
Thank you, Mahmoud. Thank you very much.
Thank you.
Thank you, guys. See you as up.
All right. Thank you.
Thank you. Goodbye.
Thank you. Bye. Goodbye. سامح.
ايوه معك.
اوكي انا I will stop the recording بس دلوقتي ماشي.